Hi everyone. In our last video, we were talking about the real number system, and we talked about natural numbers. Those were our numbers 1, 2, 3, 4, our counting numbers, all the way to infinity. Well, we talked about the whole numbers, and that's where we added 0 in to our number system. Then we discussed the integers, and that's where we have positive and negative whole numbers, including 0. We left off talking about fractions, and I didn't call them rational numbers in the last video, but that is the mathematical name for them, rational numbers. And they're just fractions. They're any number a over b, where a is an integer and b is a natural number. So b cannot be 0. So I have it stated a couple of different ways. It's easiest and most common to see it, it's easiest to write and most common to see in math is just b is not equal to 0. But b is a natural number, okay? To continue, we have one more left to define, and we should do that real quick before we move on. We're not going to spend a whole lot of time talking about it, but there are also irrational numbers. Okay, well, irrational numbers are numbers that I can write as fractions. Irrational numbers are numbers that I cannot write as fractions. Okay, so we're talking about pi. We're also talking about trying to take the square root of a prime number, like the square root of 2 is an irrational number. For our course, you'll see a lot of the square roots. You may use pi some, depending on which class you're in. Either quantitative reasoning or statistics, but I would like to move our discussion along. We'll come back to irrational numbers by the end of this video, but I would like to move our discussion along and start with exponents. Okay, so let me erase this here. So exponents. That is when we have some number b raised to the power of a, okay, and b is our base. A is our exponent. Okay. B can be any real number. A, however, for the moment, we're going to say that A is an integer. So positive, negative, whole numbers, and 0. Okay, that will change here shortly, but for the first part of our discussion, we're only talking about exponents that are positive, negative, whole numbers. The best way to go about this is just show you some examples. So 2 squared, that is the same thing as 2 times 2. Remember, the exponent is saying to do repeated multiplication of the base. So I know I have both 2's as my base and exponent, but the exponent says take my base of 2 and multiply it 2 times. Okay. It's easier to see once we add on the 3. So if I'm taking 2 cubed, or 2 to the 3rd power, that's 2 times 2 times 2. Okay, sorry about this. 2 times 2 we know is 4. 2 times 2 times 2, that gives me 8. Let's do one more row so we can see the growth. So 2 times 2 times 2 times 2, that gives me 16. Okay, so when I had an exponent of 2, when I had an exponent of 2, I had my base written twice. When I had my exponent as 3, I had my base multiplied 3 times. When I had my exponent as 4, I multiplied my base out 4 times. Okay, so here my exponents have all been positive numbers, whole numbers, bigger than 1. So when I had positive whole numbers bigger than 1, it meant to multiply out my base that many times. Let's talk about 2 situations, I guess we can call them. And that is going to be, let's use 5. I like 5. 5 raised to the power of 1. Now, every number has an exponent of 1 if you don't explicitly see an exponent on that number. But I'm not going to take 5 out and multiply it. Nothing is happening in this situation. It is the same thing as 5. Okay, so when my exponent is 1, it can be invisible. Just like 1 times 5, it's the same thing as 5. 5 divided by 1, it's the same thing as 5. I don't need to write that out. It's the same thing as 5 with an exponent of 1 joins that idea because it's just 5. So it's a 1. The easy thing to remember is that nothing changes here. The more awkward situation, we'll continue using 5, but when our exponent is 0. Now, we could talk a very long formal definition of why this is so, but the easiest thing for you to remember is that this is another way to write 1. 5 to the 0 power is 1. Okay, any base with a 0 exponent is equal to 1. Okay, it's all the same thing. So just like I could write 1 as 2 divided by 2, it's another way to rewrite the number 1. Okay, so it doesn't have any other relationship with fractions here. That might not have been the best way to explain it, but that is a time when you take the number 1 and you rewrite it in a way that looks completely different. And so that's why it was my example. So, rule. Exponent of 1 leave base alone. And an exponent of 0 we rewrite as 1. Okay, a little awkward, should be easy to remember. For your own benefit, if you stick 5 to the first power into a calculator, it will tell you 5. And if you take 5 and raise it to the power of 0 in a calculator, you will get 1. So, if in doubt, in my classes anyway, you'll have the calculator as a backup to help you remember. Okay? So we've discussed exponents when they were 0, when they are 1, when they are positive whole number integers greater than 1, so positive whole numbers. Now, let's talk about negative exponents. Okay, and I know I'm going fairly quickly, but examples and homework will follow, so you'll have plenty of practice thinking about these topics. Okay? This is going to be another kind of definition idea. Let's say I have 2 raised to the power of negative 2. The way I thought about this when I was in college was negative exponents are a lie. It means my base is not where it's supposed to be, okay? And if it's not where it's supposed to be, there's only one other place I can move it to, okay? That would be into the denominator of a fraction here. In this case, negative numbers are the opposite of positive numbers. So a negative exponent tells you to do the opposite of what you would do for a positive exponent. In a positive exponent, it was repeated multiplication. That means a negative exponent is telling you, let's do division. So 2 raised to the power of negative 2 is the same thing as 1 divided by 2 squared. That is the same thing as 1 over 4. Okay. Now, I don't want to say that it explicitly means that the number is supposed to be in the denominator of a fraction. It actually means the number is on the other side of the fraction bar from wherever you're seeing it. Let me change color here, because I could very easily see something that looks like 1 over 3 to the negative 2. I still have a negative exponent. I'm just going to take this now, and instead of moving it down into the denominator of a fraction, I'm going to move it back up into the numerator. So that's really the same thing as 3 squared. That gives me 9. Okay. You could do it with denominators again. If I rework this example, it's just a lot messier. And if you remember from our last video, division of fractions means keep, change, flip. So that would be 1 times 3 squared over 1 equals 3 squared equals 9. Okay, so instead of doing that, my suggestion is this. If you see it in the numerator of a number, even if you don't see that denominator, it really means to move it down. If you see it in the denominator, like so, it really means to move it back up. Okay. Continuing on with the idea of exponents, let's see a couple of examples where we have exponents and fractions together. It's not a scary situation, though a lot of people make it so. But again, I'm going to use parentheses. So 3/4 squared. My exponent is positive, and it's a whole number. Okay. Having the parentheses here tells me that my exponent actually applies to both my numerator and to my denominator. So I could rewrite this way. It's 3 squared divided by 4 squared. And we know that that is 9 over 16. Okay. Now, if I didn't have parentheses, and I was looking at this, I can't assume that it's also going to apply to that 4. Those parentheses aren't there. My 4, because I don't see an exponent, actually has an exponent of 1. Remember, if you don't see it, it's going to be a 1. So that would be 3 squared divided by 4. That's 9/4. Okay. And, you know, the same thing, if I had 3 over 4 squared, my exponent on the 3 is 1. I don't have parentheses, so I can't apply that exponent to both situations. I have to realize that it's different. So that would be 3 over 16. Okay. Now, what happens if I have a negative number raised to a power? So let's say negative 3 squared versus negative 3 squared. And again, my use of parentheses here is really important. We have two completely different situations. Okay, let's use blue again. So for this first one, my exponent here is 2, obviously, but my base here is everything inside the parentheses. The exponent is outside the parentheses, so everything inside of it is part of its base. So this is telling me to take negative 3 and multiply it to negative 3. So 3 times 3 is 9, but I have a negative number times a negative number, so remember from our last video, that's a sign change. That makes our answer positive. So my answer for the first one is positive 9. Now, how about we use green? Here in my second example, I don't have parentheses. So again, with the idea of invisible ones, that 2 as my exponent does not apply to the negative sign. It only applies to the 3. And if it helps, you could always think of this as negative 1 times 3 squared. Okay? So what I'm really looking at here, let's go back to green, is negative 3 times 3. So 3 times 3 is still 9, but a negative number times a positive number is a negative number. Okay? You don't actually need to rewrite the negative 1 out. That's why I didn't do it here in the second example. It's an invisible one. You don't have to keep carrying it along. It does tell you, though, that that exponent doesn't apply to the negative sign. It did only in the first case, not in the second. So be very careful with parentheses and your signs here, because it's very easy to get lost in them. Excuse me. So that's when we had negative signs involved with our bases. What happens when we have a negative sign in our exponent? Okay, so we're talking about something like 2 raised to the power of negative 2. Okay, let's show another one. Let's also show 1 over 3 raised to the power of negative 2. This way you can kind of see both situations that you're going to come across. When you see a negative exponent, what that means is that the base is on the wrong side of the fraction bar. Okay, so for my 2 raised to the power of negative 2, if my base is on the wrong side of the fraction bar, that means it really needs to be in the denominator of a fraction. That is equal to 1 over 2 squared. Notice, once I moved, the negative sign went away. That's the same thing as 1 over 2 times 2, and that is 1/4. Okay? And it's the same thing when I have my base in the denominator of a fraction. That negative sign on that exponent is telling me my base of 3 is on the wrong side of that fraction bar. And if it's in my denominator to start with, that means it really needs to go into the numerator of a fraction. So that's really 3 squared over 1. Again, it's an invisible 1. We don't actually need to write it. So that's the same thing as 3 squared. That's the same thing as 3 times 3. That gives me 9. Okay? Now, another way you might come across a negative exponent with a fraction. Let me erase everything. let's say 2/3 raised to the -2 power. Okay? And again, just like my fraction before, if it is in parentheses, that means that this exponent of -2 applies to both my numerator and my denominator. That gives me 2 raised to the power of -2 divided by 3 raised to the power of -2. Now, because the negative sign tells me that my base is in the wrong spot, I've got to take my 2 and move it to the denominator. And I've got to take my 3 and move it to the numerator. So what I'm really doing here is taking the reciprocal of my fraction. So that is the same thing as 3 squared over 2 squared. That is 9 over 4. Okay. Now, a lot of these that I've been using for examples have been pretty specific situations here. So there is another example that might come up. Let me get rid of this so we don't confuse the two. I've been using 1 a lot because it's invisible in my denominator and we don't have to really deal with anything besides moving our base. But in a situation, let's go back to this color. If I have 2 over 3 to the -2, okay, so my 2 here really has an invisible exponent of 1. It means don't do anything, just leave it alone, right? That 3 still needs to move, but my 2's not going anywhere. That 2 needs to stay right where it is, and I'm going to write a multiplication sign. That 3 is going to move up into the numerator of a fraction. My 1 is there. I took the reciprocal. I flipped it upside down. I don't actually need to write it that way. I can just go straight to 2 times 3 squared. Okay. Remember, just in case you got lost as to why, 2/3 is the same thing as 2 over 1 times, times 1 over 3. I can pull them apart as separate, completely separate fractions. So if I had a -2 here, all I'm really doing now is this situation. Okay, so you don't have to go through the whole rewriting of this statement. Just, I'm okay personally if you go from this step to this one. Okay, but we weren't actually done simplifying anything, were we? So we left off with 2 times 3 squared. That gives me 2 times 9. That gives me 18. Okay, so be very careful when you have other numbers involved in your fractions with exponents. If they don't apply to that other number, it's got to stay in the location that it's in, and it needs to have a multiplication sign with it. So for one more example, let's say 2/5 with my -2 exponent up here. That was a huge exponent. With an exponent of -2 there. Okay, so again, my 5 needs to stay in the location that it's at. It has an exponent of 1. It's got an invisible exponent. My 2, though, does need to move to the other side of that fraction bar. So what I'm really looking at here, if this 2 goes down, if I'm going to move that down, my numerator here is 1. Okay, it doesn't turn into 0. There is still a number there. And then I have 5 times 2 squared. Gives me 1 over 5 times 4, that is 1 over 20. And again, if you need to see the separation of the fractions, I'll do that in blue. 2 to the negative 2 over 5 is the same thing as 2 to the negative 2 times 1 over 5. That gives me 1 over 2 squared times 1 over 5 equals 1 over 4 times 1 over 5, which still gives me 1 over 20. Okay, so either way, again, I am okay for you to go from this situation to this one. If you need to write this step out, good. If you don't, you don't have to, and then you're going to get the same answer either way. This bottom one here, it's just a lot more extensive, but it maybe it makes more sense to some people than my first walk through of that problem. Okay, so moving along. Actually, not moving along. We're almost 30 minutes into this video. I'm going to go ahead and stop right here. The next video will pick up talking about radicals, okay, square roots. So, see you in a bit.